This is a video to go over two-dimensional motion, and we're working on a practice problem where if you have a baseball rolling off of a table that is 0.7 meters off the ground and it hits the ball, or it hits the ground 0.25 meters away, how fast is the ball initially going? With any two-dimensional motion, you always have to break it down into two parts: your velocity or position in the x direction and your velocity or position in the y direction. We always start with the y direction because the goal is to figure out how long is the ball in the air, and then we can take that time and plug it in for x. This is one of the simpler or more straightforward problems because you don't have any initial velocity in the y direction. You are only traveling in the x direction. So because there's no y velocity, usually we would say that y equals the initial velocity times t plus 1/2 acceleration times time squared. But since initial velocity is 0 in the y direction, so I'm going to put a little y there, then y equals 0 plus 1/2 at squared, or y equals 1/2 at squared. In the y direction, acceleration is always negative 9.8 meters per second squared. And in this case, we're looking for time. We know that the change in y is 0.7 meters in the downward direction. That means a negative 0.7 meters. This negative has to be there because you're using a negative acceleration. Otherwise, when you try and take the square root of time, it's not going to work if you try and take square root of a negative number. So if I multiply the 1/2, that's a 4.9 meters per second squared times time squared. And now I'm going to divide both sides by negative 4.9. So that's 0.7 divided by 4.9. And that gives me 0.143. So 0.143 equals time squared. Square root both sides, and that gives me square root. My answer is 0.378. And since that's time, that means that the ball has been in the air for 0.378 seconds. Now that I know that the ball's been in the air for 0.378 seconds, then I can figure out what was the velocity going in the x direction. For velocity and position, I know that x equals velocity times time. The change in x was the 0.25 meters. The velocity is what I'm trying to figure out, the initial velocity, and the time, I know that it was been in the air for 0.378 seconds. Therefore, I can say that it has been in the air going in the x direction also for 0.378 seconds. So I'm going to divide both sides by 0.378 seconds. That cancels this out, and if we have 0.25 divided by 0.378, that gives me 0.66 meters per second is my initial velocity in the x direction. Now, a problem like number 3 gets a little more complicated because now you no longer have a 0-degree angle. You're actually going somewhere in the y direction. So unlike number 1, you cannot use this particular equation because you actually have an initial velocity here. But we usually choose not to use this particular equation because you have time and time squared. In that case, you would have to use quadratic. So we're going to use a couple of different formulas instead, and the combination of them is going to give us an easier equation to work with. And those two formulas are these two, where your final velocity equals the initial velocity squared plus 2a change in y, and the final velocity equals the initial velocity plus the acceleration times time. So we're looking at this stuntman who is trying to clear this gap of 4.0 meters, and he has 2.5 meters of height to do it. he is jumping at a 15-degree angle. So if we're looking at a triangle, this here is 15 degrees, and he's jumping at 5.0 meters per second. This doesn't help me until I can break it down into components. So to break it down into components, I'm trying to find, if this is his velocity, I'm trying to find his initial x velocity in this direction and his initial y velocity in this direction. In order to do that, I can just create a triangle. I can say that if this is 5.0 meters per second and this is a right triangle, then I can find A and B, or in this case, X and Y, using trigonometry. So I know that cosine theta is equal to the adjacent over the hypotenuse, and sine of theta is equal to the opposite over the hypotenuse. Theta, in this case, because he's jumping at a 15-degree angle, we know that we're taking the cosine of 15. I know that my hypotenuse is 5.0 meters per second. So I'm going to multiply both sides by 5. So that my adjacent is now 5 times cosine of 15, which is negative 3.7984. 5 times cosine of 15, which is 4.83. So 4.83 is my meters per second in the x direction. So my velocity initial in the x direction is equal to 4.83 meters per second. And in the y direction, I'm going to have the same thing with the sine theta. So this is sine of 15 equals opposite over 5.0. Again, multiply both sides by 5. And if I take 5 sine 15 degrees, again, making sure I'm in degrees and not radians, is 1.29. So 1.29 meters per second is my opposite, which is here. So that's my velocity in the y direction is 1.29 meters per second. Now that I have my initial velocity in the y direction, I'm going to use this first equation here to find my final velocity. That way I can plug that final velocity into my second equation so that I can solve for time. So if final velocity squared equals initial velocity squared, and this is all in the y direction, plus 2 times a change in y, my initial velocity is here, 1.29 squared plus 2 times 9.8, or negative 9.8, times the change in y is 2.5 meters, so a negative 2.5 meters. 1.29 squared is equal to 1.66 plus 2 times 9.8 times 2.5. The two negatives cancel. I get 49. I add them together to get 50.66. I can take the square root of both sides. To get my final velocity being 7.12 meters per second. Now that I know my final velocity, I can plug it into this equation. So final velocity equals VI plus A delta T. My final velocity is 7.12. My initial velocity was at 1.29. My A is negative 9.8. And I'm going to find how long I've been in the air. So first I subtract 1.29 from both sides. Sorry, I forgot to mention that this is actually a plus or minus 7.12, and since your final velocity, if the guy is jumping up and then down, your final velocity is actually going to be in the negative direction, so this is actually a negative 7.12. If I subtract negative 1.29 from both sides, I end up with a negative 8.41, which equals my acceleration times time. Dividing both sides by negative 9.8 gives me 0.86 seconds equals my change in t. That means that he has been in the air for 0.86 seconds. And if he's been in the air for 0.86 seconds, that can help me determine how far he's going to get if he's going in this x direction for 0.86 seconds. Remember that we found out what his initial velocity in the x direction was and it was 4.83 meters per second. So I'm going to use the very simple equation that the change in position equals my change in velocity, or my velocity times the change in time, which would be x equals v times t. V, in this case, we said is 4.83 meters per second in the x direction, so initial velocity in the x direction. The time he was in the air was 0.86 seconds. Multiplying those two together gives me 4.15 meters. Taking that, I know that he can now clear this gap of 4.0 meters because he's actually going to land 4.15 meters away. So this initially is not used in your equation. It's just to help you figure out whether he's going to clear this gap or not. So recap, whenever you're doing these types of equations, you always break it up into components if you're starting at an angle. You have your initial velocity, you use cosine and sine theta to find what the components are. First, you take the initial velocity in the y direction. You use these two equations to solve for the change in time, how long he's in the air, because if he just jumps up, jumps back down with that same initial velocity, whether he jumps up and jumps down here or jumps up and lands over here, he's going to be in the air the same amount of time. You're going to use that change in time, multiply it by the velocity in the x direction, so you know he's been going this way for this amount of time, so he will stop in the same amount of time that it takes him to jump up and jump back down. I hope that's helpful.